Hello, everyone. Welcome to the Flux Dev Meeting, September 25th. Let's get started.
Hey everyone, so I think we are ready for the source control release. Danny, do you have any opinion on this? Are there any blockers from you?
Asking me?
Yeah.
No blockers. Just waiting for when do we do the release? Matthias, do you have change thoughts?
Yeah, I saw the instructions from Sunny in the Flux maintainers Slack channel to create the change log. I'll do that today and we can do the release.
Yeah, it's the release process is documented on the website.
Mhm.
So you need to have two commits, one is backported and so on, right? You need to follow the instruction. There are also create release branches, all that stuff.
Mhm.
It's quite complicated, but once you do it once, then it's easy.
Cool.
So yeah, we should strive to do the source control release. Then
Update the dependencies.
yeah, there is a new set of packages in FluxCD package. I'm not sure if source controller is on the latest. So there is a patch release for all Kubernetes packages and other things. One second, let me check. So it should be yes, Kubernetes 131.1. No, so I've updated source control. I think source control is the only one that has the latest packages. For all the others, when we do the source controller API bump in after source controller is in all the other controllers, we also need to update all packages again. Something like this. Paste it in chat. So after source control release, we should take care of image automation controller and get that Azure DevOps pull request rebased and yeah, go mode updates everything. So we could update source control in that pull request because that pull request needs the new source control API. Can you do that, Sunny?
No, I can do that.
Or yeah, so it's also I think in end-to-end tests and other things, the version of source control has to be bumped. I think we could do the Flux 2 release Monday if we get by Friday evening all the controllers released.
Would it take that long?
I don't want to
We-
release it on Friday.
No, we can release tomorrow. I think change logs are ready. That's the only time consuming thing.
I also think there are other stuff in the Flux CLI, right? Around Asia.
There's one pull request, I've reviewed it. Just waiting for you to have a look at it. It's good to be asked this.
Okay, I see. Yeah, so after source controller release, first we are going to wait for the bot to bump source controller in Flux 2. We merge that. Then DT can rebase this one. So we don't need to wait for all controllers to merge the Flux create source git modification. Another thing I want to get into this release, I figured out this morning how to fix the sharding issue around dependencies. So as you know, if you do Flux sharding, then the controllers only receive events and the controller runtime client can only query the resources, the objects which have the sharding label. And this is through cache manipulation, right? So when we instantiate the cache in main Go, we pass there the label selector to the cache. So as you know, the controller runtime client, when you do a get or a list, it doesn't actually do anything with, it doesn't reach to the API, it looks up the cache. So now the problem is that if you have, let's say, two Helm controllers, shard1, shard2, and you have a Helm release managed by shard2, and you set a dependency to a Helm release which is managed by the other instance, the shard1, the controller will fail to find the dependency. Why? Because it's not in cache, it uses the default client, which hits the cache and the cache is filtered. So yeah, be reading the control runtime source code again, and there is a thing in there called an API reader, which is a partial implementation of the client. Like the name says, API reader, it only reads stuff, so it implements only get and list. And the API reader does not store things into cache, is not aware of the cache. So what I did was passing the API reader to the function that does the dependency check and using the API reader for that. And that should bypass everything and should make this work. So there are two pull requests created for this. Yeah.
I was going through it and I was wondering, with this change, it will, like every reconciliation, if you have a dependency, it will bypass the cache. Should we check? Like, should we pass the or share the watch selector with the reconciler itself so that in check dependency, we can check if the given object customization and release, they are part of the selector or not, and then decide to use cashless, a direct client.
What do you mean? Like doing more than one query?
No, depending on the object. If the object has the label that the controller watches, then we'll use the cached client. If the object doesn't, then we'll use the direct client.
But we don't know. Because in the dependency list, you don't specify labels. How are you going to know if a dependency is labeled or not? Because it doesn't matter the object that you are reconciling. You can reconcile an object with no sharding label. What that means? That means that object is reconciled by the main instance of the Flux controllers. That can depend on an object that has the shard label and is not reconciled by the main instance. So by just looking at the object definition, you can't make any decision there because you don't know. You don't know if sharding is enabled, and you don't know if you are running on the main instance, there is no shard label attached to the object that you are reconciling. So unless you query and you look into the dependencies, you have no idea if they are sharded or not. Also, sharding is not a hard-coded label, right? It's a label that can be
It can be
configured.
anything. That's what I was thinking. In main, we have that label. We can pass that label to the reconciler.
No,
But
in main,
maybe
we
this
don't
is-
have the label.
We set the label in the cache.
No, we don't. Main does not have the label in the cache.
The sharding label we don't have in main.
No, in main, it's only it's not it's only the label key as a not condition.
What do you mean?
Do you know
not
how
condition?
sharding works?
We add a label and we just watch for changes for those objects that have the label.
No, let me give you the docs. So the main instance has a watch label selector, which is in the form of not condition, not some key. Like this. But let's restart. Why wouldn't we use direct API calls for dependencies which are, I don't know, 2 or 3 objects on the whole cluster? Like, why wouldn't we do that?
We can do it. It's just we have it in the cache. We are just doing unnecessary calls, which we didn't do
They're
before.
not unnecessary. There are a couple of things here. For example, there is also some tricks in Helm controller and customized controller for it. Like the cache gets stale all the time when you update the status. So it's basically for dependencies doing direct calls. I think it's what we wanted for the beginning, but when we started, there was no option to bypass the cache. The idea is that you want the latest version of an object, not whatever is in the cache at that moment. Because the cache can be behind. I have no explanation why Hide, when we changed Helm controller to Helm release version 2 and we were relying on the cache, we discovered that you end up with older versions when you query the cache for, let's say, 100 milliseconds or whatever. So we actually force in Helm controller, we requeue multiple times and we wait for the cache refresh. I think in terms of dependencies, I really think we should just hit the API like we do for secrets and config maps, right? And there are tons of secrets compared to dependencies. We had this issue with secrets and config maps, and caching for secrets and config maps is disabled. For example, Helm controller, right? Every Helm release has at least one secret in there. Like
Okay,
the
considering that,
dependencies are like 1% of all the queries that we make. So I really don't see a problem. In fact, I think it's actually a great optimization, because I've seen, like, on clusters with, the usual, have cluster controllers in a customization, then controller configs, then apps, then I don't know, some other thing, and you have like 3 or 5 dependencies. I've seen many cases where even if, let's say, controllers is reconciled, all the others don't see it as reconciled because the cache is behind. So you wait an extra, basically the controller does way more work because it errors out, it reschedules until the cache gets updated. But now with this change, the moment we update the status and we mark something as ready, a dependency as ready, the other Go routine that checks for it, it will actually find it instantly. You will not have to wait for the cache to refresh and all of that. So it's also a speed improvement in some way. What I will like to do, if you have time, is actually test that this thing actually works by having 2 shards, 1 shard and a main one, and have a dependency between those two. Customization on hand release doesn't matter because the code is the same. So if it works in one, it will work in the other one. But yeah, I've read like twice the API reader code, and I'm quite convinced it bypasses the cache, but it's not fully documented in that way. So again, having a unit test doesn't make sense because you need separate processes, separate controllers in Kubernetes to actually test this.
in Helm controller, at the very end of reconciliation, we have a differ where we do some finalizing things. There, we had a similar issue where if cache is not up to date, we wait and poll for the cache to be updated, and then we exit. I think we can use this client errors as well.
Yeah, I think there are lots of places where this stuff has messed up with our process, because we think of, when we do a query, it will always be, the latest version, but the cache is not write read guarantee. So you can write something in etcd, and immediately if you read it, you can get an older version, because from my understanding is you write something, you don't write it in the cache. So only get and list hit the cache. So you write something, then the controller waits for the event from etcd. This thing has been added. Then it queries and it updates the cache. Then it can take like enormous time, depending on how busy etcd is, whatever. So write operations are not actually writing in the cache, only get and list. And that's why we have these desynchronization between, oh, I'm writing now, I'm reading it in the next step, and I'm getting another result, right? So yeah, if we could look at this in the future, like where we write and we then need to query for that object and we need to get a fresh copy of the object. Now, because I discovered this API reader, we should replace the client with the API reader for those read operations. So we can get rid of pulling all the hacks that we've implemented in various places to wait for the cache. Right?
Okay.
I think it's a small price to pay a full API query than doing all this long pulling and so on, which, in my opinion, consumes more resources in the end on the controller side. The reconciliation is slower. Yeah, all these things.
I'm reading what we did in Helm controller. The comment says we do this to avoid a situation where first reconciliation did something and the second reconciliation operates on the stale object. I think this will not help with that because the first object you get, it comes from the cache, the very first object you receive when you start reconciling.
No, so you get the event in the reconciler, then you use the client to get the object. The object is not passed directly in the reconciler entry point. So instead of using the client, which is cached, you could use the API reader and read the object directly from the API when you start the reconciliation. You know for sure, every time you start the reconciliation, you start with the latest version of the object. Is that like the first line of code in the reconciler, right? Instead of having that hitting the cache, you could start with a fresh copy. Wait, now we need to figure out how much would impact the overall thing. I discovered this API reader. It was the other issues with RBAC and other stuff in some AWS controller, or no, in an OpenShift controller. And I've seen that after API reader was implemented, at the beginning of each reconciliation for that OpenShift controller, they were using the API reader to get the object, and all the other things, dependencies, secrets, whatever, were taken from the cache, but they have replaced the default client with the API reader when they start a new reconciliation. And I think this problem becomes more impactful when you run more than one instance of a controller. What's happening with sharding, basically. But yeah,
Okay.
for now, I think we can, if this actually works and we fix the sharding, we can then consider later on if we want to use more the API reader compared to the client.
So we have not
But yeah.
tested it with the sharding use case.
No, I just wrote it. I haven't done end-to-end test today. I wanted to do it, then I had this problem. I had to go to the hospital and I have to go back.
Do we
So yeah,
include
if
this
you
in
have
the
time,
release?
yeah,
Are we including it? Okay.
yeah, if it works, it will be great. I mean, it's quite an important thing to be able for dependencies to work across shards. Think of like, why are people doing shards? They want to separate, for example, they have all the infra things, and then they have tenants with hundreds or thousands of apps, right? And they want to dedicate a shard to the apps. Well, the apps customizations should always depend on the last thing that you are doing in infra, right? Let's say infra installs a service mesh. You shouldn't be reconciling any apps unless the service mesh is there, because if you do it, then you don't have sidecars. Yeah, all things breaks. And the fact that you can't define dependencies between apps and infra is like breaks the whole thing why we build dependencies, right? That's the main reason we did it. And it actually doesn't work with sharding because of the cache filter. I also like the cache filter like it is, because it makes no sense if you have like thousands of apps, right? And you have usually in infra, there are like what, 10 infrastructure, let's say 20 maximum cluster add-ons. Why would you use that much memory inside the controller that's dedicated for infra and cache all the hand releases in the cluster, right? With how we implemented, where we limit the cache, is great, because then if the shard that is dealing with just a couple of objects, there we can reduce the memory limits and the memory requests. While on the shard that's doing the bulk of apps, only there you should increase it. And that's possible because we now restrict the cache. If everything is cached, then all shards will basically have the same amount of memory. You can triple the memory. The more shards you add, the same things are cached everywhere, which is wrong, right? So it's this thing with dependencies that we broke when we limit the cache. And this report was a long time ago, made by some users found this problem. I looked it back then, and I think I looked in the wrong place. I reread the client, the controller runtime client code, and I couldn't find a way to disable the cache there. And the reason was they have this other client called the API reader, which is used to bypass it altogether. So it's a dedicated thing, but it uses the same configuration, the same kube config, everything, right? So it should work like it's documented, yeah. So anyway, if you have time, please try to test it out. If you don't, I will probably get to this tomorrow if everything is good on my side.
And I see where you're saying why we cannot determine if this object can be seen or not seen. Shard key can be anything. I see. You don't know the key. Okay, fine. We know the value.
Yeah, it's all dynamic. It's up to the user, right? They can set all these things, and it's fine like this. It's just that we need to resolve the dependencies without looking at the cache. Another thing, but not for this release, maybe for the next one. So in control runtime, you can now you can restrict a kind in the cache by a label selector. That is what we use for sharding, which reflects on watchers. So the problem right now is that you have a hand release or a customization that takes values for substitution or hand values from other things like config maps and secrets. And we have disabled caching and watching of config maps and secrets because you fill the memory, right? But we could actually make this happen. Like if someone updates a config map or a secret, they don't have to manually reconcile the hand release, or they don't have to use the customized config generator or secret generator. The controller could, instead of removing all the secrets and config maps from the cache, it could add in the cache secrets and config maps with the label selector, Flux CD, watch enabled. And then we can define a predicate for config maps and secrets with an index key of the hand release or the customization name. So when someone updates the secret, we'll receive an event and we can queue we can reconcile or add to the reconciler queue the hand release or the customization that should reconcile because its configuration has changed, right? So that will be, in my mind, really nice to have. And now that we have this label stuff, it wouldn't impact the memory usage by a lot, right? There are some config maps or some secrets, only a couple that contain this kind of configuration, right?
So
Compared
if
to all
I'm
the
just,
secrets in the cluster.
in this case, the predicate will go through the object and decide based on the label, it should be cached or not. Or
No.
it should be requeued or not.
No, not based on the label. So based on the label, we can enable caching for secrets and config maps. And it's one label that we set for all Flux controllers, something Flux CD watch enable, right? Then in handle controller and customize controller, we can create these watchers for secrets and config map with the same label selector and the index, a custom index based on helm release name namespace, customization name namespace. Like we do, for example, how we react now to source changes, right? We have a custom index. When the source status changes, we trigger automatically a helm release stuff. So we can apply the same thing that we have now for source objects to secrets and config maps. Basically, the copy paste of that predicate, have the same index in place. The difference will be for the predicate to work. Predicates work only based on cache, right? So we need to change the cache how we have it today, where we just remove secrets and config maps from there. Those are disabled. So instead of disabling them altogether, we disabling them unless if they are labeled with our own label, right? So there are two minor changes. One is instead of removing them from the cache, we add the label selector there. And second, we create a predicate maybe in package or somewhere for secret and config map for that label in the index key. And we use it in the same way we use it for source objects. So the change is not complicated. Just now that we have the right tools to make it work. So, and I'm not saying that, using customized config maps or secret generator, it's bad practice. It's great. But the problem with that is we force users into having the config map or the secret in the same overlay with the hand release. In many cases, that's true. You store the config map maybe in the same directory or something. But there are other types of configuration, like runtime configuration, the name of the cluster, the region, whatever, which is not in the Git repo. Is created that cluster creation by, let's say, Terraform or Copy or whatever infra tool you have to provision that. So you can't use a secret generator. You can't, the hand release or the customization can't be updated when you update the config map, right? You need to run Flux reconcile or wait for the reconciliation interval, right? So instead of, we could actually optimize all of that by having these watchers in place with the label selector. So how that will change the cluster provisioning when you create the config map with your cluster information, like, cluster name, region, I don't know, account ID and other stuff, you'll also add this label, Flux CD enable or watch enable. And all of a sudden, hand controller and customized controller will trigger the right customizations and hand releases that are referring that config map. Okay, I need to
Theoretically sounds
run.
good to me.
Any other things you want to ask me, anyone?
Um,
I have some
Kingdom
Flux
Hearts
operator
support.
questions, but they can wait if you have to go. S- They're just a few small ones, but they might be long answers. I'm not sure.
Yeah, let's talk on Slack.
Okay.
Later on.
All right.
I'll be back in a couple of hours. Cool. Okay, so source controller release is next, right?
Mm.
Okay. Thank you. Bye bye.
Bye.